Hello everybody and welcome to another Blender tutorial. My name is Procházka and I would like to show you this kind of effect. It will be about spawning objects to Blender's rigid body simulation. This tutorial is with big question mark because I am not sure about the method. It's not how it's quote unquote supposed to be, but it's kind of a workaround that I came up with. And I'm very interested in if you would came up with something better, and let me know in the comments what is the better or the proper way of doing this. I will create it by helping myself with animation nodes, which is add-on you can download in the description. There will be a link to it, and the result should be something like this. Some object as emitter, and from it it would spawn many randomly rotated, randomly scaled rigid bodies with actual collisions like convex hull, mesh, cube, or whatever. So without further ado, let's jump right into the Blender and let's start probably with the ground, so we have something to collide with. I am not using a simple plane, instead I am using this cube because it has actual volume and it has a really good advantage for us. I will just name it ground, and in the physics settings I can activate rigid bodies. This will be passive, no movement at all, and there is the advantage. If you are using just a simple plane, you have to use a mesh collision type for it to recognize the polygons itself, and you have to have margin on it, so it actually works properly with the collisions, but all these objects will float above the surface. But if you have the volume, as I do with the height of this ground, I can use box, and box collision shape doesn't have to have any margin, so the collisions will appear really on the surface itself. Well, this is pretty much all for the ground. Now our spawning objects, our emitter, it could be just this simple plane, and we can animate it so it will move on in our scene. So let's do it right now. Move it, for example, here. Location, put a keyframe here. Let's say 30 frames, and we will move it here. Location, another 30 frames, so 60. Let's say it will be here, location, and 90 finally. Let's see, something like this. Location. So now it's not really that interesting movement, but it is movement just for showing everything will work. 250 frames is maybe too much, so let's shrink it down to 180. Let's see, for our emitter we will need particle system. So create new. I will not use this particle system for anything physics related. I will not use it as simulation or anything. I will just use this particle system as point in space where I will later create all these rigid body objects. Start and end will be just 0, so all the points are there from the start. How many of them? 4, just see how the simulation works. I will put there some small value like 160, and later when I am happy with the simulation itself, I will crank this up to something like 600, 700, maybe even more. Lifetime something really big, so I don't have to worry about it at all. And just turn off the physics. I don't need any physics on these particles. These are just points for me, as I said. So if I run the animation, I see all these points moving around. Okay, now I just need something to spawn from these points. For example, the monkey. Why not? We are in Blender. Susan is popular there. I will put it somewhere so it doesn't participate in the simulation at all, so I don't have to worry about if something will collide it with or not. I will just put it below the ground. It will not be visible on the render, or it will not distract anything in the simulation. And then I will just go to the physics settings for this Susan. activate the rigid bodies, and the default settings is pretty much perfect for our purpose. Convex hull, dynamic, collision group first, everything is okay. So now I can just jump right into the animation nodes. So let's change the layout so we have the node editor visible, and let's do our magic there. So create new node 3. We don't need this node 3 to be executed always, just when something is changed. So I will check these 3 checkboxes, and let's start nicely from left to right what we will be doing. So first we need the particles so we can get their positions. So here particle system from object. Okay, which object? The plane. Plane is the one that is holding the particle system. It has only one particle system, so we don't need this particle systems. We can use only the active, and we have to get the locations from them. So here particle systems, particle data, and now if I connect it, here I can choose which particles I am working with. I work with alive particles. They are alive from the 0th frame, so in the first frame they are already there, and they will be there until the end of the simulation. So I have all these locations I need. Okay, so now I have to instantiate, so duplicate this Susan as many times as there are particles. So as many times as there are these locations. So I need to get the length of this list. Get length, put it right here, there, and I will name it or label it number of particles. So it's really obvious that here I have number of all particles, and this is the number of Susans I will need. So let's create them. Object instancer. We will need full copy of this object, so it's not copying only the geometry but also the physics properties. That's definitely what we need. Not the deep copy, we don't need that. And how many of these instances? Well, we just said it. Number of particles should be number of instances. And what we are instancing? Our Susan, of course. And we don't need the first Susan to be actually visible. So let's turn this off. And now all these Susans are right here. And that's not exactly what we want. We want to move all these Susans to these points on the plane. To our particles, of course. So let's create another node, object transform output, and we will move our Susans. And first check the locations in all 3 axes. Now it's 0, 0, 0, so all monkeys moved to the center of the universe, the center of the space, but we will move them to these locations. These are the locations of the particles. So if I plug it there, the monkeys will move to where the particles actually are. Well, it works really nice, but they are really big. So let's check the size in all 3 axes as well and create some vector. From value, of course. So from one value, it will just create it 3 times this value and create vector from it. So if I plug it to the scale, now it's 0, but I have one value where I can move the scale and create the sizes that I want. And to follow the nature of particle systems, I would like to this value be random or kind of random. So let's create a list of random numbers. Here it is, number random. And if I check this list value, I can create a bunch of them at once. Also, I should say that I am using animation nodes 2 point something. So if you are watching this in the future and you have different version of animation nodes, it will probably work kind of a little bit differently. So keep this in mind that I have the version 2.0.4, I believe, or something like that. So where we ended, yes, I have a bunch of random numbers, so I can plug it there. But before I plug it there, I have to make sure that I have the same number of random numbers as there are Susans, so it will actually work. So how many of them I need? Here it is. No, here it is. Number of particles. And put it into the count. So now I have how many? I think it's 160. I can find it here if I want, viewer, and plug it to this length. Yes, I have 160 random numbers from, let's say, 0.064 to 0.16, and now I can plug it to this value, and each monkey is now a little bit different size. I can play with these values, make the maximum bigger or smaller. I will leave it as 0.16 because I already tried it and I kind of like the result. And when we are in the randomization, let's randomize the rotation as well. Create a rotation where it is random Euler, and same as with the number, check this list icon so I can have bunch of them. How many? It's still the same thing, just as many as the particles. And the scale, I will put it at 1, so it's the full range of the all axes, and plug it to the rotations. Now all these monkeys are randomly rotated, randomly scaled, and placed where the particles are. Okay, it starts to be little cluttered. Let's make it a little cleaner. Okay, and what we will do with these objects. First, if I show the original Susan again here, I can see it's green, and it's green because it's in the special group, object group, rigid body world. And I have to have this in this group because when I run the simulation, it will work only on objects that are in this group. And if I turn it off again and look at my generated monkeys and select one of them, it's yellow or orange or whatever your Blender theme will show you, but it's because it's not in this group. So I first have to put all these objects in the group, and unfortunately I cannot do it with just one node, so I need to create a loop. And for clarity and to make it nice and clean, I will do it with another node 3. So I will create new. I don't need any execution at all. This will be just set group, and I will create a loop here which will be named set group. Why not? Let's use it several times, and it will go as iterator will be objects, so it will go through all these objects, and I will put it also as output object list here. So it will take all these objects and just put them outside of this loop. So for now it does nothing, but I can add some parameter, the group I will want to use, and put the object to the group. So object, group operations, I can use this object, use this group, and go back to the node 3 where I can use this loop. So here, subprograms set group, this is my new loop that I just created, and I can put these objects here and select the group I want them in. I have only one, rigid body world, so let's use it. And now you can see all these monkeys are now green, and they are belonging to the rigid body world. That's pretty much all for the settings, and now we will do the actual spawning of them. And I will just trick the simulation a little bit, because in the start I will just turn them off, let's say, and then I will randomly turn them on as the time will go. And what the turn off actually means for me is that I will turn them off for the viewport, so set them invisible in the viewport, turn them off for the renderer, so same thing, set them invisible for the renderer, so we will not see them. And in the physics setting I will turn off this dynamic, so they will not participate in the simulation at all. I will turn on this animated, so they will move with the emitter itself, and I will turn off this collision group, so they will not collide with its neighbors. So for example, these two monkeys are actually intersecting in the beginning, so they will just shoot some random direction away from each other. If I have turned off these collision groups, they will just fall down as I would like to. Okay, so it's actually 3 or 4 operations at once, so we will create group for it. So let's create new node 3, same reason as before, just to make things clear, and create a subprograms group. Well, let's name it, for example, turn on off, to know what we are doing. And first, let's turn all these objects invisible for viewport and for the render. And before we will continue, this is one of the operations that has to be in the loop. So why not? Let's create another loop in the new node 3, turn off the execution, set visibility, and create loop here. It will go through all objects, so some object list, and the parameter will be some boolean, so a value just true or false, and output will be also object list. So now it does absolutely nothing, but I can go here to the objects, visibility output, put it right there, and I can use these values to hide it in the viewport and hide it in the render. So if I connect it like this, it will actually works exactly opposite of what I want. I want, if this value will be true, I want to be visible to these monkeys. But if it's false, I want to hide them. So because it's exactly opposite right now, I will just put boolean invert here, and now it works as I want. So go back to, well, I didn't name it, so this will be our group, turn on off, and I can use my loop. I didn't name it, of course. Let's tap to the loop. It's set visible, so I know what it does. Well, let's tap back again, and I can promote these two values to the group, so it will work with some object list and with some boolean value. So now these objects will be invisible if I turn them off. What else I need to do? I need to turn off this dynamic property. So it will be something like object attribute output, and I have to find this attribute. Where it is? Here, right click, copy data path, and here, Ctrl V, rigid body enabled. This seems like this exactly what we want. So I will go through all these objects and enable them with this boolean value. Okay, looks like no errors, everything works as expected. What else? The animated value. The animated value will be actually opposite of this enabled value, this dynamic value. So copy data path, here Ctrl W, kinematic. Why it's always some different name than here? It doesn't matter now. So let's put there all these objects and the same boolean but inverted. So here boolean invert. Now it's as it should be. And for the final, we need to turn off this collision group. So let's do it one more time. Put all these objects here, find this collision group, copy data path, here Ctrl V. But you can see this is rigid body collision groups. It's not just one here, it's bunch of them. It's actually 20 values of true or false, so 20 boolean values. And for this to actually work properly, I can go here and put the index of this group. So now I have just this one group. But for some reason, if I now will try to bake the animation nodes, it will not recognize this group. I don't know why, but it will just not. If I use all these groups and create list of 20 booleans, it will just work as expected, as I want. So let's go and create the list. So list, create, and booleans, where it is, more boolean. And we actually need 20 of them to correspond with all these 20 layers of collision groups, or these 20 groups. So create 20 values and turn them off. I'm pretty sure there has to be a better way, but it's just 20 values. It's fast to do it that way, and why not? And let's put the boolean to the first one. So if the boolean is true, this will be on. If it's false, it will be off. And I think it's pretty much all for our group. Just an output node, so we can put all these objects back again where we get them. So go back to node 3 where we can use this, and here we will just use where it is turn on off. So now if it's true, I can see the monkeys and all the settings are the same. But if I turn this off, the monkey disappears in the editor, disappears for the renderer as well. The dynamic is turned off, the animated is turned on, and the collision groups are turned off. If I check this on again, the monkey appears in the editor, in the render, dynamic is on, animated is off, and collision group is on again. So now the monkey works, now the monkey doesn't work. So for start, I will just turn them off, so they are not here. I will just duplicate this and turn them on back again. So now the animation nodes from this point doesn't do anything. So we will do something on this line to choose which monkeys will be on and which monkeys will be off. So let's do it with list slice, and I can uncheck the start. I need only end. The start will be always 0, and you can already see we have only 10 monkeys in the scene. And if I set it to 1, I have only 1 monkey. Now I have 50 monkeys, and I have all the monkeys. So you can see that if I will animate this value from 0 to 160, the monkeys will appear. And also, because we are not doing it with just the visibility, we are doing it with this group that will turn on off all these physics properties. They will just start to participate in the physics simulation itself. So now just animate this value. Should be simple, but rather confusing, I'm pretty sure. We will just use the number of particles and do some simple math with that. Number of particles, and I will divide it with the number of frames I want it to appear. I hope it kind of makes sense. So, like in the particle systems, the start and end. So I now looking for the end value. For example, I want them to appear across 100 frames. So I will divide it by 100. That means this result is how many monkeys will appear in each frame. Yes, I hope it makes sense. Let's duplicate it, set it to multiply, and now how many monkeys will appear in each frame? Multiply by the frame number, where it is animation time info, and now I should have number of monkeys visible in this particular frame. So in the first frame it's 3 or 1, in the second frame it's 2, in the third frame is 3 times this value, it will be 4, I believe, already. So let's plug it right here where it should be, and if I write there like 50, I should have half the monkeys here. If I write there 100, I should have all the monkeys. If I have write it here 33, I have third of the monkeys. So everything works as expected, and I am pretty sure that the physics simulation will work as well if I just try to run it as animation. Okay, everything works as expected. I can change some values, I can play with it, mainly with the values of random rotation, the scaling, maybe, I don't know what more, the timing, of course, here, how many frames it will take to generate all these monkeys. I will keep it at 100, and before I baked it, I will just turn on more monkeys. So let's crank up the particle settings to 640. Let's say it should work. And for the baking, the process is kind of weird. First, turn off the rigid body world. Go here in animation nodes in overview and bake this to keyframes. And now when it's baked, turn off the animation nodes. We no longer need them. Everything is in keyframes on the monkeys itself. Turn on the rigid body world and bake the physics. Well, now when the physics is in cache, select all the monkeys, just select one of them and group, Shift G group. Now the third and final baking is here in the physics tab. Bake 2 keyframes the physics simulation itself. Okay, and now the simulation is actually baked. You don't have to worry about it anymore. It will be the same every time. So just you can create some nice materials for the monkeys, some lighting, set the camera and render the final result. You can see that the monkeys even follow the speed given it by the emitter, given it by the plane itself. But I didn't find a way how to actually put on them some force or some initial velocity. So if you know some Python command or some workaround how to actually move them in direction that I will specify with some vector, for example, I would really appreciate it if you can write it to the comments. And what now? I think it's pretty much all. Only one thing, if you bake all this and you want to change something, it's not really that hard. You just have to get rid of all these keyframes. So go to the dope sheet, unselect the plane itself, because I want the animation on the plane to stay away. With Ctrl I will select everything else, and X delete keyframes. So now the bake is actually gone. Free the physics bake in the rigid body cache, turn it off, turn on again the animation nodes, and bake them again. The same process. First bake the animation nodes, turn them off, turn on the rigid body world, bake the rigid body world, and select all these monkeys, bake 2 keyframes, and you are back where you were. Let's try it just for fun. Of course, let's change something. For example, the size. I will create much bigger monkeys and maybe even more of them, and bake it. Turn them off, turn on rigid body world, bake that, select all the monkeys, Shift G group, and bake 2 keyframes. Well, and that's all for this tutorial. Wow, it's probably too much monkeys. They are colliding with one another. Kind of interesting, but definitely needs tweaking. So it's all for this tutorial. I thank you very much for watching, and till the next time, bye.